Hello, welcome to our project video. Our project is basic calculator using logic gates. We are from C1 group 2. There are four of us: Tamanna Akhtar, MG Ahmed Mia, Julkarnain, and Ishtiaq Ansari. I'm gonna explain the main functions of our project here. First, I'm gonna run the Proteus file. Okay, so as you can see, our project is quite big. First, I'd like to mention something that we took the input from this logic tables and the plus minus multiplication and equal sign. We could not find the algorithm for division. It was quite hard in hardware, so we skipped that part. We will do here plus minus and multiplication. So our project includes a lot of ICs. The first one is a BCD to binary encoder. What it does, when I press 2, it converts it and sends it to the display, the 2, and if I press plus, the input disappears, and if I press 4 and equals, the answer is 6. So how is it doing it? But before that, I'd like to mention something. In our hardware project, we could not actually uh, build the displays, output decimal displays, because uh, we used here as a sub circuit for binary to BCD, and as you can see, it's quite big. It makes up of 7 more sub circuits, which is made up of uh, another big, very big part. So this was hard. This was not available in our country, so we could not actually show the decimal outputs. In our hardware project, we showed the binary outputs instead. So first is the BC to binary encoder. We used 4072 4 input OR and 4071 2 input OR gates, and then there is a 8-bit register to store the first input, and next we used an 8-bit adder to multiply the input by 10, so that it becomes a decimal place number. Next, that number is saved into another register, and I press another number, it goes to another 8-bit adder to be multiplied by 10 again. So now it's equivalent to 100 place number, and the 3 inputs are added together in this adder and finally in this adder. So in this adder we get the first input and check if it's negative. If it's negative, this added subtractor unit converts it to 2's complement and saves it another register. Next, when we press plus minus multiplication, then the register saves the first input, and these registers and adders again takes the second input, and when I press equal, this register takes the first input from this register, and this one now has the second input, and this one has the first input. So these two outputs from these registers are taken and inserted into adder, so it can add and then check if the output is in 2's complement. If it is, then it converts into normal binary number and shows the output. Like now our answer is 6, and this is showing 110. From here we used from top to bottom, from bottom to top, MSB to LSB. uh, and we took the first 4 bits of these two inputs and our multiplication circuit, and then we used a mux to check if to show the multiplication output or the addition subtraction output. And this goes into the binary to BCD, but as we could not find it in real life, we could not show the BCD outputs in display. So here is the end of our project mainly, and we can show the output in binary. Our project is basic calculator. This is our the main circuit diagram and boards, lot of wires. uh, there's a few sections, like the input section, input buttons from 0 to 9, the plus, minus, equals, multiplication and clear button, and the final output. The final output, MSB, is from right to left. This is the first input section. So our first calculation is uh, an addition 1 plus. So we're gonna see the first input 1, and the second input is 6. So the answer should be 7, right? So equals to, voila, it's 7. So our calculator works. Now we have yet another addition. It's 44, the first input, plus 55, and the answer should be 99. So let's see. And this is the binary for 99. Subtraction 7 minus 4. Here we go, 4. Okay, the answer should be 3. So let's see the answer, it's 3. So now we're gonna subtract a negative number from a negative number. So firstly, minus 8 minus another negative number, which is 111, and it equals minus 119. This is the output for minus 119. Do a multiplication between two inputs. The first input is 3 multiplied by the second input 4. So the answer should be obvious. 3 into 4, 12. So let's see our answer. It's 12. Voila. We're gonna do a multiplication. The first input is 7, and 7 is being multiplied by, again, 7. So the answer should be 49, and this is the binary for 49. As you can see, it's 110001. It's 49. This time we're gonna multiply 12, a 4-bit number, with another 3-bit number, 7, and the answer should be 7, 12, 84. And this is the binary for 84.